Let's resume from where we left. So in this particular program, we designed a perceptron, right? Okay, let's just run the program quickly to see the output. Right? So also we could see the classification, the straight line drawn uh, by the updation of the weights and the biases of the network. Okay, so let's move forward. Now we are going to look at the design of a neural network which can perform the classification of 4 different classes. So this problem was just a 2-class problem, right? So let's go ahead and do that. Right? I'll create another script by the name my custom ANN3. Okay, so here write a comment saying that design perceptron to say classify 4 classes. Okay, so this is our objective for the day. Okay, so this is what we do initially. Okay, so now let us start with the definition. So here we try to define the number of samples in each class. So start from the initialization. So let me define the num per class is equal to, let me say 50. Okay, we can change this. Then let us define the offset between each of the classes. Right? So offset is equal to 0.37. Let's try to define the smaller values. Then let us define the coordinates of each of the classes. All right. So class A is equal to. So let me generate the coordinates. Right. So I'll generate the coordinates directly using the command function. Okay. So this is random of one row, and the number of columns is equal to the. So this is the num samples per class. Okay, so this is the first coordinate, but I just have to do one thing. I just have to make sure that I subtract the say the offset from this, because this represents the first something like x axis values, right? Followed by, let me define another one. Okay, so that is random one row number of samples per class, and I want to, let's say, uh, perform the plus now. So you'll understand what exactly happening. Okay, once I create all the 4 classes. All right, so this is plus say plus offset. So that is for the first class of the data set. Right. Let me similarly, let's create class B. Class B is equal to, let me create very similar fashion. This is random of say 1 number of samples per class. I want to okay, previously I subtracted. Now I do the plus plus. Okay, so this is also plus plus offset random of 1 number of samples per class. So see, both I am doing the plus and the plus offset and plus offset. So you see the difference, right? X and Y coordinates, one all negative, one positive. Second class is plus plus. The third one will be plus minus, and the fourth one will be minus minus. So that you have the properly defined class. Okay, so that is class B. This is class C is equal to, yeah, I'd like to copy this and paste because everything remains same except the plus or minus the offset value. Right, so let's see this now. So I'll perform plus and the minus. Only this is the difference. And let's go for say class D is equal to, I'll just paste this, the difference being both the offsets are subtracted. So random numbers will come. So since there is difference among the offset values getting either added up or they are subtracting them, right? You can see that there are differences. Okay, now let us try to so this is what I call as, right, define the classes. Let's try to run check whether we can see this. Okay, all right, so all the classes have been created. So once the classes are created, now let us try to plot the classes. So this is what is, I'll try to write the code for plotting of the classes. Okay, now so plot the four classes one by one. So for the first one, this is plot. I'm trying to plot the class A. Okay, so the class A of, write the first rows and all the columns. Okay, first row, comma, all the columns should be plotted, right, as the first coordinate, comma, same thing, same class, but you you plot the second. Okay, so because A and B are classified generated, like you see the first row, this is the first row because I use a semicolon here to go to the next row. So this means you are creating 50 samples in the first row, 50 samples in the second row. So 50 first samples are to be, right, plotted as the x coordinate, are considered as x coordinate. Now the y coordinate. Okay, so class A, the second row, all the columns. Right? This is what I'm trying to plot. But I want to make sure that I use a separate color. So what I do now, I give the specification. Okay, so let me try to give a specification ds. So this will plot the points, right, on points from class A in blue color, S for square, PS for blue squares. Okay, so let me just verify whether this runs. You see blue squares are wrong, right? So these blue squares are corresponding to the class A, right? All right, so let me go ahead and turn the grids on. Okay, and I also want to hold on because I want to plot all the four classes on the same graph. I don't want to change. So plot, right? Uh, Class B, first row, all the columns, comma, class B itself, second row, all the columns. Okay, let me give again another specification here. So let me change the specification to a red colored plus. So how do you denote that? This is R plus. Okay, so quickly run this just to verify. Now you see, you can see two different classes. Right? So two classes because, right, we already plotted the for class number one, that is blue colored squares. Now I added this. So since I called hold on, it's holding. Then this is plot class C, right? I want to plot the first row of the columns, comma, class C, the second row, and all the columns. Give a specification that say I want to plot green colored and the zeros. Okay, okay. Circles. Okay, just see, this is class 3. All the three classes are visible now. So since we used that uh, offsets properly, they're classified, they're already generated four different classes inside. Okay, so plot class D, 1 comma colon, class D, 2 comma colon. And right, let me go with a different color now. So say I use this plus only. Okay, let me go to the start. So four different classes should be visible when I run this. Just check. Okay, so four different classes are clearly visible. Okay, so we created the data and we plotted the data. So let's give some names here. Let's give the text also. I'll show you how to give a text. Yes. So text. Now again, I need to specify where I should plot. Okay, so approximately I'll try to watch. So approximately this should look like this. Let me get the classes. So the first coordinate of my class would be 0.7 minus offset. This is the x coordinate of my first text, and 7 plus 2 times. So at this particular point, I want you to I want the machine to plot. I want the machine to give a text. Okay, so the text is class E. Let's try whether this works. Okay. So, okay, it's coming somewhere here. I want it somewhere here. So I have to move it to the left. Maybe I'll reduce this. Okay. So this, let's make 0.5 x coordinate and y coordinate should be, oh, okay, class A. So okay, 0.7 y-axis should be, yeah, okay, somewhat fine, right? So this is how it means it is class A. I can bring it down, right? So this is 0.7 plus 2 into, okay, so like this we can actually set the values related to that. Okay, so 5. So you can see it comes at the center, right? You can adjust it so that you can move it to this any point like this, right? Like that we can move. Anyway, I'll skip that one. Otherwise, it will take some time. Simply skip this, right? Anyway, we understood that those are the classes. I just wanted you to get introduced to the uh, text concept. I think we didn't discuss that when we discussed the basics. Okay, but anyway, we can definitely. Okay, right. So, all right, let's move further. Right. So once this is created, now let us define the output coding for each of the class. Okay. So if the output of A, right, I want to, okay, I'll write the full name. Output of A should be coming like this. That is, say, if the data sample which we give for testing is from class A, this is how it should look like. It should be 0, 1. In the output, it should be 0, 1. All right. Similarly, the output corresponding to B should be equal to, this is 1, 1. Then output for the class C should be, give another number like 1, 0. Then it's not class D, sorry, it's output. Class D should be 0, 0. So 4 classes have been defined. Since the classes are 4, we cannot give like just 0 or, right. So let us try to uh, define our inputs, right? How we define our inputs, let us try to define. Okay, so first, input all classes is equal to, so first it's class A, followed by, this is class B, followed by class C, class D. Okay, then let us try to define the targets, right? So targets equal to, you see, corresponding to each class, I need to create the classes now. So the targets now. So the first is, right, it should be for class A data, which is the target. Target should be this one, right? See this one. 0, 1, 0, 1, 0, 1 should be repeated so many times as many number of class A elements we have, right? So because of that, let's try to do the rip mat now. Repeat the matrix, right? That is from output A. So which matrix should be repeated? That matrix. So this is output A, comma, I should tell how many times. So one row and the number of columns of that of matrix A. Okay, so length of, so A is class A. So class A, whatever is the length, repeat it so many times. Okay, that's the first one. Followed by repeat the matrix. Output B, because second one is B, one row and length of class B. Repeat the matrix. That is output C, comma 1, length of the class C. Rib mat output D, comma one row and the number of columns equal to length of class D. Okay, so I missed another bracket. That's why it is showing an error. Okay, so let me just, all right. So we created the target, we created the inputs. Now let us directly start with the what you call, okay, after the plot, I will go for a new thing. So here we define the inputs and the targets. Okay, once this is done, now in the next part, let's define the neural network. So net is equal to perceptron. So I declare that I'm going to use a perceptron. All right. So now our intention is to design a perceptron which uses the adapt function. It's a better classifier, and there is a lesser error in this. Okay, so let's try to do that now. So let me start with the an error coefficient e is equal to 1. Okay, and so we are using the adaptive nature. So this is parameter dot is equal to. So you define that initialize with the 1. Then I just have to tell that what should be my line handle. Okay, so line handle is equal to, we have seen this function, that is plot PC of weight, and the biases should be right used to calculate that. That's why. So this is net dot, it's a IW of 1, comma, next one should be bias. Okay, so this should be net dot B Okay, now, so the line handle has been defined. Let us directly start with the iteration number n equal to, you can start with n equal to 0. All right, now, so start training while we calculate the parameters such as the SSE, while the SSE of the E and the number of iterations n is actually less than, I would like to go with say 1000. When this happens, I have to make sure that n equal to n plus 1, increase the iteration, then update your network. So that is the net, comma, the output y, comma, error e. This should be equal to the, the adapt. I'm using this particular learning mode. Okay, for net, comma, uh, I think we defined the inputs. So input is defined all here. That is input all classes. Pass input all classes and the targets. This actually trains the network and change the line handle, because once there is something that is training up, I can actually update my line handle as well. Okay, so this is plot PC dot net dot B1, comma, old line handle. You see what happens because of this statement is, you will be, you can see that as the training progresses, what happens to the lines. Initially the line will be something different, but as the training happens, we will observe that there will be more and more updation of the weights. As the weights and the biases get updated, you will see the line changes their position. So ultimately, after 1000 iteration, you'll see the final lines coming up into picture. Okay, so that is visible here. That's why I'm writing this particular command. Okay, then I'll call this is draw now command. So what this draw now command does is immediately it will plot the straight line. As and when the line handle gets updated, you will be able to draw. Okay, so sorry. End of the while loop. Right? I'll just call, if required, you can call, I'll just write a one. View the network. Right? This is optional, so I am writing. Okay, so this actually trains and we will be able to finish the training. Design ANN and we actually included the training as well here. Okay, so let me go with that. So if you could observe, the lines are actually slightly moving because initial weights are different. I'll run once again. You just see, So you see actually the lines are moving. Maybe I'll try to make this as slightly increased number. So just see that. Now you see actually the lines are moving. Can you see? Initially some line will be there, but later on it will move, right? Right. So that's what is the training process. I'll increase this further. Now you can see the lines are moving further. It will take some more time because the n is 10,000. Sorry, I think more than 10,000, 1 lakh now, right? So it's very clear that the lines move, right? And so training is over. Now let's go for the testing phase. You define your own testing input. Okay, so test input is equal to give two values, any two values, such as maybe 0.75 and 1.25. Let's see. This is the test input. And perform. Why? The output is equal to, I have a network trained. To this you pass the test input. Alright, so let's run this part only now. Okay, only the last part I'll run. So run the section. You can see the output. Oh, sorry, something happened. Okay, it has to be, there has to be a dash. Say it is 1, 1, right? You can see that 1, 1 belongs to which class? That is class B. Okay, like that. You can change these values and you can check where the values are going to come. If I make it this as say 2.25 and let me try to run this, maybe that's still 1, 1. Point 0, sorry, 0.05 and this number. Let's try to run that. That is 0, 1. You see class is changed. Okay. If I make this as 0 point this, then the class will change to 0, 0. You can see the output here, right? In the command window. So the classes get changed, right? One class to another class as and when we change like this. Okay. Yeah. So just check that. Do you have any doubt with this? No. Okay. Now Okay, I'll give you one homework question. Okay, so this is the question. So here the classification of the perceptron, right, was able to distinguish between the four classes, correct? Now, is it possible to design something which classifies six classes? All right, you have to generate the data in such a way that you have six different classes, right? So right now you have four classes. Think how to create the six class data set. First thing is that, so once you have six classes properly visible, right? So maybe I'll tell you what are the options we have. So you see here there are four classes like this, right? Either you can add two classes at the top, right? Two more classes, one here, one followed by. Then you see you can have total six, or two you can add to the right side of these four classes, so that top row will have three classes, second row will have three more classes. Okay, so that is what is required to be done initially when our target is to classify the six different classes. Okay, then once it is done, in the next step, right, you have to design, you can take any neural network, right? It's not necessary that you have to use only the one which we used just now, that is a perceptron, right? Absolutely not. You can change and you can take any other neural networks structures which we have already used in many other codes. Okay, select any one of them, and after you select that, uh, design that in such a way that it will classify uh, two more classes. In the sense, you have to draw one more line. That's all. One more straight line needs to be drawn. Correct. So that actually classifies your class number 5 and 6 separately. I think the red colored line will definitely, right, class will definitely separate the uh, top layer and the sorry, top neurons and the bottom neurons. That is for sure. But how do you classify the other two parts is the question which you need to solve.